Most students lose marks in arithmetic progression, not because it is difficult, but because they miss the foundation. Let me break it down step by step. Let's consider the sequence on the board. This is an AP. How do we know? Because by adding the same number to each term, we get the next term. For example, the first term here is 1. By adding 3 to 1, we get 4. By adding 3 to 4, we get 7. By adding 3 to 7, we get 10. By adding 3 to 10, we get 13. So what is the next term? To get the next term, we add 3 to 13, right? And that will give us 16. That is how you know an arithmetic progression. Let's consider another sequence. 21, 17, 13, 9. This is another arithmetic progression. So what is the pattern here? By subtracting 4 from 21, we get 17. By subtracting 4 from 17, we get 13. By subtracting 4 from 13, we get 9. So what is the next number? If we subtract 4 from 9, we get that number. That number will be what? 5. Not so. What does these two sequences tell us? It means that an arithmetic progression, AP, is a sequence where we add or subtract the same number every time to get the next number. That is it. That is, when all we do is to add or subtract the same number each time to get the next number, that sequence is an AP. Note that each time we are adding the same number to get the next number. In this case, we add 3 to each number to get the next. And in the second case, we subtract the same number 4 to get the next. And the number we are adding every time to get the next number is called the common difference. So, common difference, the number we add each time. But how do we find the common difference in a sequence? To find the common difference in a sequence, we subtract each term from the one that follows it. How do I mean? Let's say we have 2, 6, 10, 14, and so on. How do we find the common difference? The common difference this says subtract each term from the one that follows it. That is, subtract 2 from 6. So it becomes 6 minus 2. Or, common difference can be 10 minus 6. Or, 14 minus 10. In each case, we get 4. 4. 4. That is why it is called common difference. And the simple formula is common difference D is equal to second term minus first term, or third term minus second term, or fourth term minus third term. Let's demonstrate it with this sequence: 2, 5, 8, 11, and 14. What is the common difference? Common difference is equal to second term minus first term. Since our first term is 2 and the second term is 5, common difference will be 5 minus 2, and that will give us 3. Let's look at another AP. 33, 28, 23, 18. What is the common difference? Remember, common difference is equal to second term minus first term. That is 28 minus 33. Therefore, common difference is equals to minus 5. This is to show us that the common difference would be positive or negative. Now, let's talk about the nth term. What does the nth term mean? Let's consider another sequence: 2, 6, 10, and 14. In this sequence, 2 is the first term, 6 is the second term, 10 is the third term, 14 is the fourth term. And if we want to find the fifth term, it's easy, right? Once we know the common difference, we can get the fifth term. So what is the common difference? D is equal to, let's use T3 minus T2. The third term minus the second term. The third term is 10 minus the second term is 6. So the common difference is 4. Since we know the common difference, if we add the common difference 4, so the fourth term is 14. We will now get the fifth term. The fifth term will be 14 plus 4, and that will give us 18. 18 is the fifth term. Now what if you are asked to find the 50th term? Yes, find the 50th term. Will you keep adding 4 continuously? That is where the nth term comes to play. But what exactly is the nth term? The nth term is a plus n minus 1 times d, where a is first term, n position of the missing term, d is common difference. Now let's demonstrate this with real examples. Let us use the same sequence as our first example. The sequence is 2, 6, 4 and 14, and we need to find the 50th term. We start with the nth term. Nth term is equal to a plus n minus 1 times d. What is a? A is the first term, 2. What about n? N is the position of the number we are looking for. Get this right, because this is where many students mess things up. The first term, 2, is occupying the first position. The second term is 6, occupying the second position. The third term is 10, occupying the third position. So there's a number occupying the 50th position. That is the number we are looking for. So n here means the 50th position. So we say n is 50. What about d? D is a common difference, and we have said that d is equal to C2 second term minus first term. If we do that, second term is 6 minus the first term 2, 4. So d is 4. Now we substitute these values into the formula. That is, the nth term is the 50th term is equals to 2, which is a, plus n. N is 50 minus 1 multiplied by 4, the common difference. So the 50th term will be 2 plus, always resolve the brackets first. 50 minus 1, 49 times 4. So the 50th term will be 2 plus 49 times 4, 196. Therefore, the 50th term is equals to 198. So that's the job of the nth term. It helps us to find any missing term without going through the stress of adding a common difference repeatedly. Let's consider another example to reinforce this principle. Okay, in this example, we have the AP 35, 33, 31 and 29. Find the 12th term of the AP. The sequence is 35, 33, 31, 29 and so on. Since we are looking for the 12th term, we use the nth term formula. The nth term is equal to a plus n minus 1 times d. Now we define each of these unknowns. A is equal to 35. N is the position of the number we are looking for, the 12th position. D is second term minus first term. That is 33 minus 35. Therefore, D is minus 2. Now that we know A, we know N, and we know D, we'll now substitute those values into the formula. So the nth term, which is the 12th term, is equal to 35 plus 12 minus 1 times minus 2. This will be 35 plus, always resolve the brackets. 12 minus 1 is 11, then times minus 2 times minus 2. This gives us 35 plus 11 times minus 2 is minus 22. Next, positive sign multiplying negative sign always wins. So we have 35 minus 22. Therefore, the 12th term is equal to 35 minus 22. That will be 13. And that is it. Now you know how to find the nth term. Now let's look at a real WAEC problem. The problem says the 8th term of an AP is 31. The first term is 3. Find the common difference. Let's see how the solution goes. From this problem, we have the first term to be 3. The 8th term is equal to 31. And we are looking for the common difference. How do you think we should go about this? We'll use the nth term formula. The nth term formula says A plus n minus 1 multiplied by D. We know A will be 3. We don't know D. Do we know n? Yes, the 8th term. So n in the 8th position, n is 8. And what is in the 8th position? 31. Since we have only one unknown, we can now find the common difference. So we say 31 is equal to A. A is 3 plus n is 8 minus 1 times D. We don't know D yet. Now let's resolve the brackets. Remember, always resolve the brackets first. 31 is equal to 3 plus 8 minus 1 is 7. 7 times D. 31 is equal to 3 plus 7 times D. 7D. We say 31 minus 3 is equal to 3 plus 7D minus 3. We subtract 3 from both sides. 3 minus 3 we cancel out. We now have 31 minus 3. That gives us 28. Is equal to 7D. Next, we divide both sides by 7. 28 over 7 equals to 7D divided by 7. 7 we cancel out here. 7 here is 1. 7 here is 4. So we have 4 equals to D, or D equals to 4. And that is our common difference. Now that you know how to use the nth term formula, the next step for you is how to find the sum of an AP. I will break that down in the next lesson. But before we go, do this. Find the 15th term of the AP. 6, 9, 12, 15 and so on. Drop your answer in the comments. Subscribe for more lessons like this.